I'm Frank Iacovelli. I'll be doing the presentation. My background is I've been with aPriori for 15 years. I've spent most of that 15 years working on the machining product, although I've pretty much done everything. My background is CNC machining and CAD design. What we'll be presenting today is the latest advances in machining, and we're kind of following a theme here as far as um, just what designers can do when you quickly assess geometry, alternative designs based on DTC feedback, alternative or looking at building and optimizing routing processes, and finally what sourcing can do if they're armed with all of this information. So to begin, we're going to start in the aPriori platform. Here you can see I've got a part that I've already costed. And again, it's process group, where you want to make it. aPriori chooses a routing, and then material, annual volume. What we're going to look at first is just the notion of model-based definition and what exactly that means. And then also, I want to look at the geometry extraction and the richness of our geometry extraction, because this has been improved over the years. Then we're going to look at DTC and how that's used. And then material nesting, which is something new that we added, where I can take this part, nest it on a plate, and see if I can't optimize my material utilization, which ultimately is going to save me quite a bit of material or quite a bit of money on material costs. Here we can see we've got a material utilization of 7.6%. Keep that in mind because we're going to lower it when we nest this thing on a plate. And then finally, we're going to look at matrix costing, where I can take this part and automatically create multiple scenarios in different regions, different volumes, different batch sizes. And so it automates a lot of that, which I would have had to do manually. So to begin, model-based definition. As the raw geometry sits here, I can take it, I can extract it, aPriori can extract it and pull geometry from that. We're going to dive into that. But what the model-based definition does is if I come over to tolerance policy and check this, it'll go and look in that CAD file for any information as far as material, cosmetic threads, tolerances. What it's going to do is automate a lot of the selections that I have to do. You can also embed a process group, a VPE, or digital factory secondaries in that part, and then completely automate the costing process so that you don't have to do anything. You run it through Cost Insight Generate, it's going to auto-generate a cost. But for now, what we want to do is go take a look at tolerances. If there were tolerances in this model, they would appear under Design to Cost. And then if we do Review Tolerances, here you can see that the different tolerances were a diametrical, flatness, positional tolerance. We're getting much better at assessing the tolerances put on in the CAD system and then figuring out which operations to push those to. If you didn't have tolerances, you'd have to assign all this stuff manually. Here, it happens automatically. So that was one big thing. Again, you can pull material automatically, but model-based definition is getting more and more traction as we go, and it's going to further automate and simplify the costing process and also make it more consistent from user to user. If we go in and look at the geometry extraction, here's our typical stuff. This is based on the process group of stock machining, but we've put a lot of effort into the roughing, and that lives under volume. So you have a stock trim. That's where the material utilization comes from. Before, all we had was bulk removal for roughing, where what it did is looked at the part, looked at the volume of material removed, and then calculated a roughing time based on some algorithms. What we've added is pockets. And they've been around for a while, but they continue to improve. And what you can see here is different pockets, different sizes. This one you take note of, it's 95 seconds to make that pocket. If we go zoom in, you can see there's a little tiny radius in the corner. So the system's smart enough to select the appropriate tools and understand that it takes longer to machine it. Versus this pocket on the same side only takes 23 seconds to make. Again, it has fatter radiuses. It's a better designed pocket unless this is for some specific reason other than the engineer wanted to put a small round there. Also slots here. So these are basically areas that we've identified that aren't necessarily a pocket, but might be undercuts, different things like that. And in the past, we didn't have these. When we went to assess this, it would have put it on a 3-axis mill, but you wouldn't have been able to do it in 2 setups, or this geometry would have come up obstructed. Now we can identify this undercut geometry. Here we have a groove milling operation for each of these. This also works for dovetail cuts. What it does is it cleans up quite a bit of stuff. So these are just some geometry enhancements. Another one is hex stock. So we've added the ability to pull in hex stock. And if we go to Our cross section here, there's our stock trim. We can automatically pull hex stock for this part, whereas before this is a lot of our customers were asking for this. So now it'll automatically grab that piece of stock, throw it on a lathe. If you don't want the hex stock, you can go back and explicitly choose your material. So we're going to go back and take a look at the design to cost stuff next. And there's a few things in here. Design to cost isn't necessarily this tab, but it's also got to do with your heat map, your material utilization, your number of setups. So don't just think that design to cost is in here. With the heat map, some of my favorite things, and there's a lot of different views that you can take from here, is concave radii. And this one, you have to kind of understand how this works, but what it does is assesses what, or highlights with colors, what your geometry looks like. And you can assess rounding strategies. So in this case here, this is what I like to see. This is the best way to, the best rounding is where you've got your walls one color, your floors another color, and they're very consistent. You only have two different colors. So you can machine everything with one end mill. Sometimes you can't always do that, but this is optimized. And then on the other side, I have not optimized. We have different size radiuses, 3 radiuses coming together, which is problematic for machining, different size floors. What this is going to do is force you to use all different size tools, make it a lot more difficult to program. So when you go through and assess your parts and you're looking at these, if you can make them like this, that's a big deal. And then the other thing is a quick look at just features to review. Here, this is showing me this side is good, this side is bad. We've got a side mill length to diameter violation here. Here we have sharp corners on the floors. Here we have what has as a contour corner condition, where you've got 3 radiuses coming together. All these things add cost to the part and make it more difficult to manufacture. So you want to go in and look at features to review. The other view of this, and I said there's multiple views, is under design to cost. Here we can see that if we go in and review, we have a side mill length diameter violation, which we saw on the heat map. If you don't understand what that is, you click this, it gives you a little blurb of information. So there's a lot of rich geometric information in here, which is going to help you design a more manufacturable part. The next phase of this after DTC was material nesting. So one of the things that I had highlighted was that we can now do material nesting. This has been available in sheet metal for a long time. And the way we do this is we access the perimeter of the part. So we've got multiple perimeters. aPriori chooses the perimeter that you're going to nest in. What I'm going to do is go in and say, for the stock, we want to choose plate stock. And what that'll do is go in and look at my library and find the different plates and find which one this fits best in. And then you're going to see our material utilization kick up. Now you've also got process setup options that are going to allow you to control the spacing. It'll control the grain direction of the part. There's a lot of different spacing, grain direction, how the part is machined out. So what we're going to see here in a moment is that the utilization is going to go up. It's going to nest the plate or the part on a plate. I can pull a plate from my library, or what I can do is explicitly define a plate size on the fly. And then when it comes time to machine that part out of the plate, I can go in and water jet cut all the perimeters and machine each part individually is one option. Or what we can do, did it to me again. Hold on a second. Plate. Oh, I know what I missed. Sorry about this. This is my second time through and I messed it up twice. If I go under nesting here, and then I want to choose plate cut with drop off and apply that. So what this does is the default is all bulk milling. Perimeter milling with drop off will allow me to nest a part on a sheet and then mill out the perimeter of the part with tooling tabs and then come back and pull each of those parts from the sheet. That's one option. And then plate cutting with drop off is the other. What that does is it'll go in, nest the parts on a plate and water jet out the perimeter. And then you machine each part individually. So here what we can do is you see my material utilization has gone to 10.67% from 7. If we go in and look at this material nest layout, we see the part nested on the sheet. With process setup options, you can control orientation of the part, if grain direction is critical, the spacing between the parts, the spacing on the edge. So you've got a lot of flexibility to do a lot of what-if analysis and optimize your material utilization. And then finally, the last thing I wanted to cover was under matrix costing. This is something Again, it's now can be used in any process group. It can be used with assemblies. But what I can do is say, I want to make this thing in 3 different regions, 4 different regions, whatever you want, in annual volumes of 10, 50, 500, 500, and 5,000. And then we want to do it in batches of, let's say, 12 per year. What it's going to do is add all these different options in here. And then when you hit go, what it does is it throws this out to a bulk cost, brings back the spreadsheet so that you can tweak things, and then ultimately puts it all on a roll up for you. And then you can now have this roll up where you can again begin tweaking things. And then to go in with the rest of the flow, you can bring that roll up into cost insight design or cost insight report and then do different analyses. This was just an ad hoc report that I created yesterday where it looks at the region, the volumes that I machined them in, and then this is tracking the cost. So as the volumes go up, the cost goes down. Oh, wait, do I have that backwards? What does this say? Scenario, annual volume. As the annual volume goes up, which is over here, here's my cost, that's going to begin to drop. So you can track all of that stuff. So with that, that concludes the presentation. Do we have any questions? Ishan, you want to try to manage that?
Yes. So for everyone who's on the call right now, if there are any questions, again, feel free to put those into the Cost Insight Conference website under our Advances in Machining section. Or if you prefer, go ahead and unmute yourself and ask Frank or myself.
So any questions? And again, please keep in mind, if you saw anything you like, my email is out there. Let me go to that. Please feel free to contact me and we could give a custom demo for you to roll through and show any of this stuff. Oh, let me go back here.
Frank, we have a few questions that just popped in.
Okay, what do we got here?
Cool. So Leon asked, can the matrix costing be used for assemblies?
So at this point with matrix costing, they will cover that in the session. But for right now, I don't know that matrix costing can be used for assemblies. I don't think it can, but that question will be answered in the matrix costing. Ishan, take a note of that stuff, or take a note of that, and we'll send a message because I could find out pretty quick.
Will do. Thanks, Leon, for the question. And then we also have another one from Alistair.
Alistair, how you doing?
His question is, do you need a bulk costing license to do matrix costing?
I think you do. Again, I don't know the answer to that one either. Well, that's good, Alistair. That's another one we'll have to get back to you on. But it'll be answered in the matrix costing session. And I hate to speak ahead and not know the answer to that. But there's a matrix costing session. We'll definitely answer that. But Alistair, Ishan and I will send you an email as soon as we're done with the answer to that question.
Cool. We do have a few folks from the aPriori side who also hopped in on the chat, and so they are able to answer both of those questions.
Oh, excellent.
Craig mentioned that matrix costing does work for assemblies, and you do not need a bulk costing license to use matrix costing.
All right. Well, that's good. Any other questions? All right. Well, I guess that's going to conclude this presentation. I guess we'll wait and we'll do a second presentation, but it looks like we had quite a few participants. Thank you, everyone, for joining us. And I hope you reach out to me and we'll be able to answer any further questions. Again, feel free to shoot emails, ask any questions, and we're wide open to help you with anything that you need. Again, thanks for everyone for your participation.